Dun, 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 dun. Are we all in this one? Are we all in this one?
Indeed.
You're funny.
Hey, everybody. Periodic table, groups, and periods. Let's get some targets up in here.
Let's get some targets.
That's right.
After today's lecture, you will be able to understand the modern arrangement of the periodic table and periodic law.
Yeah.
Are you okay with that?
Get to the lecture.
The lecture.
Electron shells and the period organization.
After last video,
You got to start it
I'm
off.
starting.
All right. Each period is going to represent the number of energy levels that we have. These are also called electron shells or orbitals.
Yep. So just let me pick up the pen and show you. 1, 2, 3, et cetera, et cetera, et cetera.
All the way down.
Is exactly what we mean in that sense.
One has one shell, two has two, and so on. Same pattern all the way through.
Yep.
And
Go for it,
the other way we're looking is, as you go from left to right, you are adding one more electron to the energy level, and that'll change the property of the elements.
Yep.
So write this one too.
Sure.
Have one
One,
over here, two
two.
over here, three,
Nice.
4.
How'd you get your pen to be so fine?
Some settings.
I'll have to check that out.
We went to thin pen.
Ooh.
Keep it neat.
I'm going to do that.
You would do that? See, learn something new every day.
Right.
Oh, learn today.
Yep.
All right. Left side is metallic. Right side is non-metallic. We've said that before, but do you think it's important?
Yeah.
Do you think we're going to say it again?
Probably. Moving on, right? Each step to the right leads to more non-metallic properties and less metallic properties. So if you're considering the elements in sequence from left to right, like we read a book, every step you go to the next, to the next, to the next. That next element is less metallic than the one before it and more non-metallic. So
Right.
as metallic properties decrease, non-metallic properties increase.
Yeah,
Okay.
that's a simultaneous thing. We need to not be confused about that. It just depends on which way we're talking about, metallic properties or non-metallic
It's
properties.
exactly the way the question's asked, which makes
Sure.
it so challenging sometimes.
Yes. Now the groups, they go up and down. Okay. The last electron added to the element are on the outermost energy level. That's valence electrons. Okay. All the elements in the same group have the same outer electron configuration. And now that is specifically in the ones in this picture that are height. Because the transition elements get a little weird in that regard.
Yeah.
As far as their number of valence electrons.
Fortunately.
Okay, they don't follow necessarily the procedure. And since they have the same number of valence electrons, they will all react in similar ways. This is very, very important. That might be the most important part of this particular slide right there. You might want to put a star there.
Oh, yeah.
Okay.
Groups have another name, families, because they share similar properties due to their common number of valence
Yeah,
electrons.
some really flip out when you put them in water.
And others don't do jack. But the fact of the matter is in the same group, they react similarly. And since most human families have similar characteristics, like visually, like, oh, you've got your mother's eyes,
Right.
we call them families for that reason.
Yeah.
That's what I got to say about that.
Nice. These ones don't go away. That's weird.
Ah, well.
Reminder about Lewis dot diagrams. Remember, you know anything about those?
Sure. In the middle, you're going to have your element symbol, and around it, you're just going to have your valence electrons. Those are the outer ones. So the first two go next to each other, and then after that, you're going to go around.
Kind of like this. Exactly like that. Little refresher from last year.
Yeah.
We're just talking about valence electrons.
Oh, wow, that's it.
Whoa. Whoa. You know what's good
Groups
though?
and periods, because this next video coming up is going to take a little while.
Yeah, it is going to be
So we had to give you a short one. Remember, groups up and down, periods left and right. Each one has its own properties related to it. You can tell me group number and period number for an element. I can instantly tell you how many valence electrons and electron shells it's got.
Yep.
Because I know the pattern. Group is the number of valence electrons, excluding the transition metals. Period is the number of total electron shells.
Yeah. I'm going to take one
It's
more
like-
second
It's
to
like
add on to this.
Battleship, really.
Ready? Groups 17 and 18 and 16 and 15.
Yeah.
It's the number in the ones column of the group.
We
just
used to
show-
call these group
Yes.
3A,
Yes,
4A,
yes.
5A, 6A,
And
7A.
then the transitions were the B way down.
Right, indicating the main group elements where this periodic pattern of valence electrons really holds up. When you get to transition metals, there's extra levels of energy levels, and
We're
the
not going
calculus
there.
kicks in, and we're not going there. But just know what you got to know about transition metals is they make colored ions in solution.
True.
And they don't follow the pattern of rules for groups for the number of valence electrons.
True. They react differently.
The tall groups on the periodic table do.
Well, and they're right there on that picture.
Yeah, right. The short ones don't follow the rule.
No, they don't. And guess what? We're going to follow the rule. Like the button.
Take the button, I turn off the video. This isn't recording now, is it?